Hey folks, welcome to my channel Number Pen. So today we are going to look at a few rules around the algebra of differentiable functions, right? So the first rule is what we have on our screen. The derivative of the sum of two or more differentiable functions is equal to the sum of their derivatives. That is, if u and v are two differentiable functions, then d by dx of u plus v equals du by dx plus dv by dx, right? So we often call this the sum rule in differentiation, and we're going to look at the proof for this sum rule, right? So remember, u and v are again functions which are dependent on the independent variable x. We've been asked to prove d by dx of u plus v equals du by dx plus dv by dx, right? So we let go back to our first principles. So let's assume my f of x, right, is equal to u of x plus p of x, right? That's the assumption here. Remember, u and v are again functions which are differentiable and they're dependent on the independent variable x, right? So, what is my f dashed of x, right? My f dashed of x is nothing but my d by dx of f of x, right? So, let's write that. So, my d by dx of f of x is equal to my d by dx of u plus v, right? U of x plus v of x, right? Now I go back to my first principles, right? And I'm going to write the definition of d by dx of f of x using first principles. So my d by dx of f of x, we are assuming that f of x is a differentiable function, so we don't have to worry about our left hand and right hand derivative. We can use one of them to define our derivative, right? And what is that? I go back to my limits, limit h tending to 0 and my d by dx, and I'm going to pick up the right hand derivative. And when I write this function, I'm going to write it like this, right? F of x plus h minus f of x divided by h, right? And so when we expand this further, right, we have an f of x plus h in the numerator, right? And what is my f of x plus h? When my f of x equals u of x plus p of x, and let me highlight this in yellow, I can call out my f of x plus h in terms of u and v, right? And how do I do that? All that I need to do is u of x plus h plus v of x plus h, right? And my f of x is nothing but u of x plus v of x, right? So I just write that down, u of x plus v of x, right? And I still have my h in the denominator. And we see that my numerator is u of x plus h plus v of x plus h minus u of x minus v of x, right? And looks like I can rearrange this function, right? I'm going to combine my u terms and I'm going to combine my v terms and just rearrange the numerator of this equation in the subsequent line, right? So let's do that and let's see what do we get. My u of x plus h, when I combine it with u of x in the numerator. I'm going to combine these two LO terms, right? Let me highlight it in LO. And I can rewrite this as u of x plus h minus u of x. And then I have my v terms, which when I combine, let me highlight them in green. I can rewrite this as v of x plus h minus v of x, right? So let me do that. V of x plus h minus v of x. I do a that divide by h, right? Now I think we are very close to what we want to prove, right? So I'm sorry, folks, remove this equal to here. And then I'm going to just rearrange this, do a little bit of more work here. So this is what we have. And when I rearrange this, right, I can rewrite this as, I'm going to use my bracket again here. U of x plus h minus u of x divided by h plus I have a v of x plus h minus v of x divided by h, right? So all that we've done is we have broken this down and we have re-represented this as part 1, which is u of x plus h minus u of x divided by h. And then my part 2 is v of x plus h minus v of x divided by h, right? So now I think we have, so the green term is nothing but my u dashed of x, right? And u again, like, drawing your attention to what I mentioned initially, it is again a differentiable function dependent on the independent variable x. So my u of x plus h minus u of x divided by h, limit h tending to 0, is nothing but my u dashed of x, right? And similarly, my v of x plus h minus v of x divided by h, which is the yellow part of the term, is nothing but my v dashed of x, right? So I'm just gonna, so this term is nothing but my u dashed of x, which is my d by dx of u of x, right? So my d by dx of x of u of x, which is du by dx. You don't have to explicitly mention x out here, it's quite understood. And then my LO part of the term, which is again, I'm going to pull out my pen and showcase it to you folks, which is v of x minus h divided by, sorry, v of x minus h minus v of x divided by h, which is my v dashed of x, which is plus d by dx of v of x, which is written as dv by dx, right? So that's how we arrive at the proof of this particular rule, which we often call as the sum rule in differentiation. And remember, folks, you can extend this to n number of functions, right? So if f of x equals u plus v plus g plus h, then your d by dx of f of x equals du by dx plus dv by dx plus dg by dx plus dh by dx. Remember, all these functions are differentiable in the real domain and are dependent on the independent variable x, right? So that's how we arrive at the proof for the sum rule in differentiation. I hope you found this video useful. Please do subscribe to my channel and support. Thank you.